1. We should be live. Let me check on YouTube because I don't want to, talk for 40 minutes and then discover that we are not live.
Yeah, sure, no problem at all.
It would be annoying. But actually, I don't see us on YouTube. I don't know why. Hmm. Oh, yes, we are on YouTube. There is a delay. So when I start the streaming, we are not yet on YouTube, but we are already recording. So people are not seeing us, but after some seconds, they see us saying, "Are we live?"
Oh, yeah, I
Anyway,
completely follow.
it's okay to start in this way because, as I wrote, this is meant to be a totally informal talk between mainly two persons. But as I wrote on social networks, people are not only allowed but also welcomed to participate using YouTube web chat and state their opinions on what we're saying or asking our opinions about something or stuff like that. Do you agree, Alex?
Yeah, fully agree, sure.
Great. So maybe it's good to start with a very, very quick presentation just to let people know who we are. Do you want to spend like half a minute to say people who you are?
Yeah, sure. So, as you can tell, as you can see from the video, my name is Alex Rusu. I'm a consultant and a solution architect. I mostly help companies of any size scale their uh, cloud computing efforts across various vendors. So I'm an engineer at core. I always like to consider myself as an engineer, and I'm someone who gets things done and also builds the dreams of other people.
Great, great presentation, really. Yeah, I don't want to spend many words to describe myself because if people reached this video, they probably know who I am. Anyway, I will just say I am a database consultant specialized in open source databases. So basically, problems. I help companies who have problems with, scalability or performance or, disasters of various types involving data. And I work especially with startups, but not only that actually. So the reason why I wanted this to be an informal chat is because I think this discussion makes more sense if it is, shared between more persons, as many persons as possible, because it's important to hear everyone's opinion, especially people who don't agree with us, because, you know, talking with people who agree can be can be neat, but
We
it's
we
not
call that
necessarily useful.
we call that an echo chamber.
Yeah, I totally agree. So, as everyone hopefully read from the title, the topic is how cloud computing changed company cultures. Uh, it is a topic that we kind of privately discussed in another occasion, but uh, we will talk as if I don't know your opinion and you don't know mine, right? So let me start with uh, small introduction. First of all, I think it is an important topic for anyone who works in a modern company because it's interesting to compare what companies are today with what they were before. I mean, before the advent of cloud computing, and what probably they should be, because all of us have opinion on how companies should be. Um, Well, basically, cloud computing was a massive change. Uh, it is mostly positive, in my opinion, because it gives us a lot of new possibilities. It makes a lot of things easier, but it comes with drawbacks also, right?
Of
And
course.
we will kind of discuss this like point by point. But let me start by saying that probably the biggest change introduced by cloud computing is the DevOps philosophy. Uh, why? Well, let's talk about how DevOps became important, in my opinion. First of all, cloud computing is about ease of starting machines, destroying machines, not paying machines that you are not using because you simply destroy them, uh, because you know you can recreate it anytime you need them. Um, and this, of course, has a lot of consequences, but basically the idea behind this is much less expensive than managing physical machines or virtual machines that are running on physical servers owned by you, right? Because it's not easy to add new physical servers, destroy old ones, and so on. Um, and basically, apparently, all you need to do that is proper automation, right? Some good automation in your company, which allows you to start and configure the machines you need. And do it while applications are still running, possibly. And to do this, well, you basically hire DevOps. And if you read, the famous Google book about site reliability engineering, probably in the introduction, it said DevOps are system administration made by developers, which is an interesting concept because yes, they are developers, so they can implement properly the automation we need, but they don't have specific competencies about all the technologies they use. I mean, they are generally very smart guys. They can study what they use, but it's different to hire someone whose work is basically to manage those technologies every day. What do you think about it, Alex? Sorry for the long talk, but I
No
needed
worries.
time to express my opinion.
No worries at all. Well, first of all, I would like to salute our viewers, especially from the live comments there. Hi to everyone. Second of all, well, you see, you've said an interesting thing, and this is rather common in the industry. Um, DevOps per se isn't a job role; it's a philosophy. And it does have its ground on many years back, and mostly during the Toyota time, when they actually took something that was rather established, like the famous Ford production line, and they've done incremental small changes from the engineer side that had a compounded effect on the overall efficiency. Small changes, but highly effective, and especially from hands-on, on-the-site engineers. It wasn't something that looked really great on theory, but rather disastrous in practice. But I would like to say the other way around. So this DevOps is mostly a new philosophy, and this philosophy is mostly about trying to break the old rules where you have different departments that do create products, but they basically do not talk to each other. Everything is a black box. In getting them more engaged and getting the system administration side, for example, more engaged hands-on with the whole software process delivery, and also getting developers to see the other side of the field. Because till the DevOps current started to attract, to develop, basically, we mostly had one rule, and I do think that you agree, Federico, with this one. Engineers, developers, pretty much didn't care about the infrastructure at all. They only cared about the code. And in some regards, this is valid to this day. But we've seen a transformation in this process where sometimes you need to be in those shoes, in those boots, as the Americans say, to actually see it from a different perspective, from a perspective where, let's just say, for example, you have an engine, a physical engine running. You cannot reverse the rotation of that engine in microseconds. You need an engineer with experience that will know how to slow that engine and then reverse it. If you would do it right at the click of the button, that engine would explode in a matter of seconds. From a software perspective point of view, that would be excellent. It executed exactly what you wanted. But from a practical point of view, it's a complete nightmare. Because at the end of this process, both the sysadmins, the engineers hands-on, also with the software developers, need to create a workable product. And it doesn't make sense for one side to be really far ahead and for the other side to be behind and just working in the same companies from different floors, but basically creating black boxes. And as you can see for yourself as an open source enthusiast, there's a different perspective when you build something from the ground up. And if my memory serves right, there is a very famous quote that I like. Every software engineer who actually worth their salt, is the real thing, should also care about the hardware. And this has been a lot of this has had a lot of traction, especially around big software companies. Most of them actually started to care about the hardware because it was lagging behind the software. So this DevOps perspective, this new perspective, what we should look at is trying to be a whole team rather than being silos that pretty much care just from point A to point B. And at the end of the product, we keep on going in circles rather than caring about the full product cycle from the first line of code written to the first customer that's using this service. Would you agree on this perspective, Federico?
Yes, I agree with more or less everything you said, especially the part when you talked about, DevOps breaking all the rules and how can I say, stop having different departments that are black boxes. That is something that was actually very much needed, even if I don't think that it completely happened yet.
Oh, of course. So the theory from the practice, well, sometimes there are two different distinct things, but we need to have some sort of a frame, of a common framework that we can work, or at least know how this is supposed to work, and try our best to follow it. And you know what, even write it from scratch from time to time if it doesn't work like we're supposed to. For example, why do you believe that this DevOps, for example, didn't happen anytime sooner, especially in the software world after the dot-com boom, for example, in the 2000s?
Oh, well, I believe at the time, most dot-coms had much simpler infrastructures. So first of all, probably it wasn't needed. Do you agree?
Well, I like to see this from a completely different perspective. So if we can take 2 steps backwards from where we are now, so we can look at the forest rather than look at the trees. I do believe that somehow it had to do with the financial meltdown of 2008 and the aftermath of that. And allow me to explain further, if I may. Uh, I do believe that companies, especially startups, were pushed to transform the software release cycle to produce products to release to the market in a much faster rate than in the 2000 period. And uh, from that request created this new philosophy. So this DevOps philosophy was rather an effect and not a cause. The cause was shipping things much faster to a much larger scale than it was possibly imagined before. Even in 2000, it wasn't that much of a competition. There were a few large players, but we didn't have this multiple startups that we experienced during the 10, 12 years so far. And I do believe that they had a problem and they wanted to ship things faster and break the old uh, deadlocks, the old blocks. So this emerged as a solution to that problem. And for example, I do see a lot of companies that now push 10, 20 software releases a day. This would have been unimaginable 20 years ago, for example. It would have involved some processes and some uh, events that they weren't ready yet for this one, and especially at this global scale.
Yes, I think these are very interesting points, and I agree. I agree that DevOps contributed to make the release cycle much faster, and probably cloud computing itself also contributed a lot, right? Because mm, you know, if you make a change to the production software, and that change needs to introduce maybe more machines, or maybe the change itself turns out to have some problems. Well, you could revert it, um, but sometimes companies also try to simply keep it and add more machine to distribute more the workload and keep the application fast. Do you agree on this?
In regards to keeping it, that would make more sense on the stateless part of things. On the especially as your background contractor and consultant for databases, once a migration has been run, it isn't quite the easiest thing in the world to revert it, and not particular the migration, but the effects of the migration. You have new data flowing in and populating the changes that you've done. So on the side that doesn't care about the state, absolutely, that's quite easy to scale. It's quite easy to revert. It does make a lot of sense, but it does make a lot of sense. Sorry, but on the stateful side, like databases, file stores, especially things that need to keep its state, it's not that easy sometimes, and the reverting process could not be as straightforward as possible. As we, from a DevOps perspective, in order to gain speed, we've mostly virtualized layers. So now you don't need a physical person, a person to be there in place and click a button or generate a process. It can be created automatically, but there is a downside to all of this. We have increased the complexity of the software products, and we have basically created an object out of everything. Everything is a giant Lego block that we can build. The problem is when you request for a virtualized layer, for example, and that misbehaves. And we do see serious engineering efforts in trying to overcome this faults For example, one of the companies that's leading this way is Netflix, for example, and they have an entire showcase on chaos events happening and destroying intentionally their infrastructure just to see how it behaves. And they went from regions to entire continents being unreachable. So they went to extremely great lengths just to prove this, which I found extremely interesting from an engineering point of view. How much can you actually virtualize? At what extent is there any sort of limit to this, or are we going to virtualize even more as we will have much larger blocks?
Yeah. Okay. First of all, yes, I agree, especially on the first part. Uh, I think that some DevOps could object that most of the commits probably don't imply any migration, which is true. About the commits that do imply migrations, I agree that it's not really that easy to undo a migration unless it is on, on particular cases. For example, you create a table, okay, that undoing that it is not a big problem. But when you go to alter some big table, well, it can take hours or days, and you don't want to revert such a change just because it wasn't designed properly. And that's actually, in my opinion, one of the bad effects that cloud computing had on companies' cultures, uh, because they tend not to consider enough these kind of problems. Um, I mean, the illusion of being able to add stuff, remove stuff, revert stuff very easily also brings you to sometimes not designing what you are going to do, not testing properly, uh, not implement properly. Um, and well, that can be avoided, of course, because you can always implement proper tests, proper development cycles, um, proper CI, of course. But as a matter of fact, often companies lack the the skills, I mean, persons with the skills that are needed to handle certain technologies properly. And databases are probably the most obvious example, because most DevOps actually uh, are not database experts, and probably if you ask them what is the worst pain in the neck they have, they will tell you that it's migrations, because
Yeah.
because they hate to do them. They hate not to be sure if they are doing them properly and so on. What do you think?
Even we certainly see a lot of procedures in testing before production, all sorts of tests, all sorts of recreating the environment from scratch, and so on and so forth. Uh, what we do actually also spot is that databases is something that wasn't disruptive for a long time. And yes, we had newcomers like the NoSQL movement, for example, that also try to that will also result as a necessity for a lot of the issues. But leaving that on the side, for the traditional databases, yes, we've seen improvements from version to version, but we cannot say it was a huge milestone from what we had in the past to what we have now. For example, even uh, basic stuff like replication. For example, creating a replication for an average first-time developer. having a database replicated somewhere just for reads, for example. That's a process that has pretty much remained the same, and it involves a lot of time and effort to get done, rather than having it in a few clicks and leaving the automation, the orchestration, to do the heavy lifting for us. And while some products on the market may be a bit better than others, and I do agree, overall we didn't see this. We've seen this disruptive on the stateful part, on the computing side of things. We've seen it on, for example, content delivery networks that also take a lot of the pressure from big spikes. But on the stateful side of things, we've seen, for example, changes for the file store in terms of ZFS, which was something completely out and fresh and new, and also in hypervisors. But on the database side, there was something lurking from years to years. And to be honest, if you had a skill like SQL for the past 20, 25 years, well, that pretty much in its essence, of course, remained the same. You could have used that for a couple of tools, the knowledge and the know-how. So it was set up for a change, a big change in this regard. And yes, like I've said, most of the times we confuse this new role, this new philosophy, with an actual role, with an actual person. And this is the problematic issue of it all. It needs to be a philosophy embraced by the whole team, including from top to bottom. And if this isn't done properly, if this new spirit of decentralized, of 24/7, of asynchronous rather than having synchronous processes all over the place, these are the building blocks, this new container revolution. It may not be the fastest product on the market, but even with the penalty, it does solve an issue of isolation of a capsule, of a software capsule that you can have identical across the entire globe. So we've seen a lot of amazing products. And here, Federico, if you will allow me to ask a question, 12 years ago, we didn't have companies like Slack, Uber, WhatsApp. They didn't exist back then. And to be honest, they represented a new change in the way we do things. You try and opening side by side a Slack window versus an old chat client. They look very different from what we used to have. In order to expand and grow, I believe that they've mostly used cloud computing as a vehicle to get across the markets. For a small company, for a startup specifically, it's quite hard to establish a presence, for example, in Asia. We may have viewers that during this chat, they can establish a new setup running in whatever part of the globe they would actually like at the click of a button, and they could be done with it by the end of today. So it has clearly provided some interesting instruments to expand and sustain that immense growth. And the beauty of it is you do not need anyone's permission per se, or you do not need a third party to get that done. You have the tools in front of you. You can do it everything on your own. You can build your own cloud computing, like most of the enterprise companies like to do, to own the full product, or you can go to a third party solution. It's all there for you, or you can even build it on your computer yourself. And that's something that I truly enjoy. And I do believe that cloud computing was an at the essence the vehicle that allowed these companies to grow to the levels that they are now. My question is, can you imagine if that happened 10 years ago? What's going to look 10 years from now on? What we're clearly not seeing now because we're just looking at the trees rather than the big picture.
So you mean if cloud computing were born 10 years in advance?
No, not per se. We have clear see that cloud computing in its first stage allowed
Mhm.
for rapid growth and rapid evolution of software. Right now, we're reaching a point of maturity. Can we make a exercise in the future what the new tools of cloud computing are going to leverage for the next 10 years? How is 2030 going to look like if we have already virtualized a lot of the layers?
Oh no, I really cannot answer because it's also a dangerous question because most of the times, if you try to foresee what will happen, you say something that after a couple of years looks incredibly obsolete. So, so I will not try, but I see your point and I agree with you, and I think that probably cloud computing was a sort of natural evolutions of how servers are managed because simply because it was uh, needed to sustain the current needs of new and old companies. And were there possible alternatives? Maybe, but we will never know because if there is a possible idea but no one has it, it will remain uh, a possibility for science fiction but nothing more. Um, Overall, uh, I am happy with the fact that cloud computing exists. And even if I mentioned some flaws, in my opinion, of the cloud and of the DevOps philosophy, it's simply because nothing is perfect and even a good change has bad parts. And recognizing them is useful because you see problems and you can try to address them in your company. So that's my spirit. I don't want to criticize and say let's travel back in time. Uh, it's not my purpose. Um, you mentioned something very interesting also because you mentioned NoSQL databases, and I think they are strictly related to cloud computing. First of all, because mm, if you look at their marketing, one of the things that they advertise is that they scale better than relational databases, which is mostly true. Um, Relational databases were not designed to scale simply because they were designed a lot of years ago. Um, which is not completely true also because if you look at so-called new SQL, uh, which is basically SQL databases designed to scale, well, actually they could uh, replace classical relational databases, but they have a problem. The problem is if I use MySQL, I'm using something that was born in the 90s and it's incredibly battle tested. Well, it's it still has a lot of bugs, but for example, there are also people knowing those very old bugs. There are workarounds explained everywhere and so on. Um, if you use a modern solution, even if the solution is good, well, you don't know its problems yet. You will have to find them out by trying, which could be okay, but not for everyone, honestly. Um, NoSQL, in my opinion, are not a good replacement if you want to use them for the general case. Why? Because relational databases don't scale because they address very well problems that are very hard to uh, to solve scaling. Okay. So, for example, transactions, making sure that every write you do um, will persist even in case of a crash, um, constraint checks, and so on. It's not impossible, but still it's hard to solve them while scaling. Still, NoSQL databases can be great for more specific uses. For example, I don't know. Let's mention Cassandra. I don't know if you know Cassandra, but I like it because it only answers a specific type of queries. It will not answer any other queries. Okay, it's meant to filter and order data by the primary key. Um, and it does it very well. It does it better than old relational databases, faster. It accepts writes at a much higher speed. But what if you use it and you don't understand its perfect use case? Well, for example, you will try to use it without understanding that it's quite common to lose data changes under certain circumstances, which is okay under certain use cases. It is very bad under other use cases. So I think that actually NoSQL databases are also another example of good technology which requires specific knowledge, and sometimes companies don't really have it. What do you think?
Well, this is a very interesting this is a very interesting topic. Uh, to be honest, and especially to our viewers, I'm more cutting edge on the stateless part, where of course you can have much more options available in terms of using cutting edge technology,
Mhm.
and also less risk due to its nature. You can also afford to lose a part, but you still have a part remaining. On the stateful side, where things are a bit challenging as always, I'm a bit of old fashioned, so I do tend to go with the mature, with the battle tested products. For example, I was very surprised to hear that even, of course, if they're using it at a completely different scale, we still have big companies using MySQL on on a size we could not imagine. Yes, of course, with custom patches and all, but in in looking at it from a general perspective, it's pretty much the same software that you're using on your box. But of course, with the mention of custom patches to adapt to the different changes. So, uh, especially for their critical products. So, I would like to say that specialized uh, issues really require specialized tools, particular for that task, and it may not be quite the best thing in the world to try to get a specialized tool to be general and somehow sort all of your needs. That might not be a smart thing, and especially to do that in production. It may be something like great experiments on a very something you can afford to lose. And from uh, from my memory, even the big banks that wanted to adapt to NoSQL to a lot of the systems at one point started to push back to the traditional databases because, yes, they did sort it one problem very well, but since they were at their initial phase, for example, they created more problems that they sorted, especially in this first phase. And it takes time to let things settle and see all of the use cases for that particular tool. I'm most confident that in the couple of years, as those products, those once new products will become much more mature, they will try and sort issues. For example, I do remember from my experience, MongoDB and replication. It wasn't something of a pleasant experience at first, especially in those first years. It was something more of a trial and error rather than an established process of doing it.
Yeah. That's very interesting. Can you elaborate this last part about your experience with Mongo?
Oh yeah, sure. So as I've mostly worked with software companies, uh, we have all sorts of requirements based from product to product, and I've did experience firsthand this growth in NoSQL databases, and it was something hip and cool. And to be honest, it was quite interesting. But coming from an operation side, I've always looked at the worst cases that aren't something on paper. They will happen at some point, and we need some established procedures and that will get us out of trouble. Sometimes it may not be the best way to experiment this in production, of full-blown production. And the tricky part of it is you need years in running that, so you make sure you encounter the full cycle of a software product. If you're just going to test that for 3 months in ideal conditions with the ideal use cases, well, of course, it's going to be the most amazing things, but uh, this is the same for hypervisors, for example. Yes, they may be cutting edge on what we see now, the new release and all, but at the end of the day, as a business, something that you want is to be stable first and performance second. For me, at least, being performance first, just to crash and burn afterwards, isn't going to be quite a pleasant experience, especially for me trying to sort things out.
Mm, yeah, I agree. Uh, yeah, I think we discussed a lot of interesting things, and I could continue the whole day if I didn't have anything else to do. And probably you also have something else to do. So I don't want to keep the discussion too long because after a while, probably some people will get bored. But it is probably interesting enough to make a second part at some point, right?
Oh yes, yes, surely, Federico, I truly fully agree.
Great. Okay, let's talk about it and let's do it sometimes. So, do you have anything to add before we say bye to our viewers?
Well, I would like to send a message to our viewers, and
Mhm.
it's a message of hope, of innovation. Uh, most great companies didn't happen by chance. Most of the interesting companies occurred during very interesting times. The harder the times, the more interesting the companies that evolved from those times, because they needed to adapt and overcome and establish new business models. And sometimes those new business models spread like wildfire. You can surely remember social media. It wasn't the big thing that 20 years ago. It was mostly a very obscure word, but somehow someone identified this market and it has been spreading like wildfire since then. So I do believe that in this year or in the aftermath of these years, we will see very interesting companies that will try to put the establishment on its head, the big companies on their own head. And I do hope that this will happen also to the cloud computing world. I for sure welcome the new Oracle, for example, entering very strongly on the cloud market. There was definitely a need for a fourth direct contender, and I do believe that it added a balance to the competition and to the options that we have. So I welcome this new future. It's going to be one very interesting, and it's certainly not the one that we can imagine. It will be something much more different, and especially these new startups that are going to use all of this technology to as a vehicle, so they can address much wider markets than we could have ever imagined.
I agree with you. It's a beautiful way to conclude this talk. Let me just add that these innovations will surely imply also great technology innovations, especially in the fields of technologies that allow us to scale better, and also in stateful technologies, as you say, because, uh, well, as you said, scaling them is a problem. Reverting changes to them is a big problem. So we still don't have ideal solutions, and I'm sure we will see great ideas in the future that we don't imagine today, as it happens regularly in human history, right?
Right, absolutely. I completely agree, Federico.
Great. So, thank you a lot, Alex, for this very interesting talk. I can't wait to have another. Thank you to everyone who watched us. I see that the number is not huge, but everyone watched us until the end, which is absolutely great. Um, and yeah, see you soon.
Thank you for having me, Federico, and also thanks to all of our viewers who stayed to the end of this show. And I'm looking forward for the next time when we can discuss even in more detail what's happening in the cloud computing world and especially what's next.
Great, great, great. We will. Bye,
Thank you.
Alex. Bye,
Goodbye
everyone.
to everyone.